Good afternoon. Welcome to the last session of the Developer Conference for 2020. Thank you for attending, and I hope you've all had a great day. Before we continue, we have a little bit of housekeeping to take care of, and it's the code of conduct that applies to 2020. This will be familiar. You'll have seen it in numerous talks today. And also, it's kind of common for across all of the different conferences and that. So we just need to be aware of others, be friendly and patient, be welcoming and respectful, open to all questions and viewpoints and understanding of their differences, and be kind and considerate to others. In other words, we just need to be courteous. As you've probably been aware if you've seen the keynote, the cause that we're donating to is the wonderful National Museum of Computing. If you're not aware, the National Museum of Computing is the biggest museum for computing in the world, and it's a great resource. We should be really proud of it. So any fundraising that's being done, any donations you could give would be vastly appreciated. I'd like to thank our sponsors, Black Marble, Microsoft, Sage, Grey Matter, Landmark Information, IO, NDC London and University of Hull for stepping up and sponsoring this event. It would have been very easy in this year, 2020. It's been a horrible year for many people, and the sponsors have been really kind and really generous in coming forward to sponsor the event. If you're enjoying the talks, if you've got any questions, we're out on Twitter. Please reach out, talk to the speakers, talk to the behind the scenes team. So who am I and what's this talk? The talk is API first, building APIs quicker with SwaggerHub. I'm Peter O'Hanlon, and I've been a proponent of SwaggerHubs for quite a while now. I've written about it and I have regular interactions with the team behind it. So I'm here to talk you through how to do API first, what API first means, and how you can use it to accelerate your development. So why do we have API first? What is API first for? Well, APIs are first-class citizens. When we develop services, when we develop applications, we treat things as these are first-class citizens. Everything revolves around that API. As part of this, you get that upfront collaboration, that goes on between the developers, it goes on with analysts, it goes on with your clients, product owners. Getting the right API can be the difference and the make and break of an application. Just look at the great services you use that have a great API, and then look at the ones that have a poor API experience. The ones you want to work with are the ones that give you great features that are easy to use and that make sense. What we're looking at here is the typical life cycle that some customers tend to follow. I tend to do this. So we have a design approach where we do design, have a feedback cycle for version 1 and version 1.1, version 2, and so on and so on. This feedback cycle is all around getting that contract right up front. Before you've written a single line of code, getting that design in. Getting that design right also enables you to get out tests quicker. Those tests give us the ability to say, right, okay, this is what our API looks like. How do we want to use it? How do we want to test it? Can we create some mock data? Can we create mock endpoints? So testers can be testing again before we've written a single line of code. But great API tools also provide us with the ability to take those designs and those tests and that mock information and generate code that we can start to develop with. It gives us code that we've got boilerplate models are created. They can be recreated at will. So as we go through this cycle of this iteration going down to that version 1, the version 1.1 and so on, we're continually refining the models. We're finding out what works. We're keeping the tests in sync with the development. With this parallel stream that's going on of design and test and development, it's become so easy to accelerate your development because you're hitting the ground running, you're getting the tests in place, you're getting the development in place. You've got feedback instantly, you know what works, your developers are hitting the ground quickly. And ultimately, that leads to a quicker route to production because you're no longer concentrating on writing that boilerplate for your models. What you're doing is saying, I've got models, I know how they work, I'm getting them created. At the same time, I'm going to create this production application out of it. So the models are coming out. It's up to you then to put the business logic in. That API first approach removes a large overhead of what needs to be done. So let's actually have a look at SwaggerHub in action. And from here, what we're going to do is actually build our first SwaggerHub pages. Okay. So what we have here is a SwaggerHub landing page. When you sign into SwaggerHub, which is at app.swaggerhub.com, you're brought into this hub page. In the hub page, you can see any APIs that you've worked on. You see them in order that frequency. You have the ability to add new APIs. You can create folders to organize your APIs into logical structures. There's all sorts of features there. You can come in and from this, you can go in and manage team structures. So you can go in and say, okay, I'm going to create some teams with this. So these users, I can treat them that they can just view APIs. These users can edit APIs. These users are administrators. You can invite people in. All of this can be controlled from this central hub. What I like to do when I'm creating an application is I like to create projects. So a project is just a way to group logically related items. You could tend to think, if you're coming from something like a domain-driven design background, that a project could equate to a bounded context. It's just a grouping that says everything here relates to this one particular area. So what I'm going to do is create a couple of projects to create APIs under. I'm going to create a project from this create new. And you've got these options here, whether I want to create a new API. I can import the APIs and create domains, organizations. Now the domains here are not domains as in domain-driven design. We'll come to domains very shortly. So what I'm going to do is create a new project. Now, I've created an organization here called Developer Days 2020. And in here, I'm going to create this project. The project name I'm going to call Music Shop. And it's just a straightforward case of filling in the data on the screen. So if I create that project, what happens in here? We get this little folder in here. Now, what we can do in here is add APIs into there. But what I'm also going to do, before I actually go and add any APIs, what I'm going to do is create a new project, which I'm going to call Common. Oh, sorry, my apologies. It actually, before I finish adding the domain, I need to go through and finish adding team members. I need to add any APIs that are available. I'm just going to save that. Jumping ahead, I apologize. And what I'm going to do is go back and create the new project. This second project is common, and I'm going to use this to sort common features as we develop. So I'm just going to finish creating this off. Okay. Right. What I'm going to do is I'm going to create a simple music shop API. So if I just go back to this create new button here, I'm going to create a new API. When we click the create new API, it gives us the ability to select templates to create, or we can create a blank. So we can create from a template, or we can create from a blank. This is a great way to get started in if you've got a pre-built template and you say, I want to learn about how SwaggerHub works. Once you've learned a bit about how it works, chances are you're going to jump straight to this and go and select no template. So we've got a couple of choices for the open API versions. We can go for a 2.0 or a 3.0. I always choose a 3.0. Keep it up to date with the latest open API standards. But if you had an existing project which had been developed under 2.0 and you wanted to keep consistent, then it's possible to go and create a 2.0. Okay, I'm going to give it a name. Create the name without any spaces. And we give it an API version. So all we're doing is filling in a little bit of boilerplate here. So this is just a title that's going to appear. And the description. The title and the description may not appear useful if you're just thinking from a pure API point of view. But one of the things about SwaggerHub is it's used to produce documentation as well. So from the point of view of actually starting to think about your end project experience, it makes a lot of sense to get the description and the title in early on. In projects I've been involved in, what I've done is I've set standards. You can actually set standards with SwaggerHub, and I've set the standards to say, I'm going to create this project, and I'm going to, whenever I create anything in here, it's going to have a description, and I'm going to have an example. I'm going to make it meaningful for that end experience. The key thing here, remember, is what we're doing is building something that is suitable for that collaboration. That collaboration means it's not just for the technical teams, it's for your product owners. Some of this is for marketing teams because they may have specifications, they have their ubiquitous language about words that you can use and words you can't use. So it's a great place to get that community feedback that helps build that great API up front. Okay. The owner of the project ties back to this. So that actually goes back to this organization here. Commercial enterprise versions of SwaggerHub allow you to have many organizations. SwaggerHub can be hosted on premise, it can be hosted in the cloud. So you can have a SaaS version, or you can go with a hybrid cloud model, or you go with this on-premise version. How you choose to configure it and how you buy it and what you do with it is entirely up to you. But from this, we can create these owners. This organization allows us to actually say, if you're building inside a big enterprise, you may have SwaggerHub as a standard across that enterprise, but then you may have the organizations mapping down to individual areas. For consultancies, they could be clients, as an example. Going to choose the project. The project is Music Shop. Now we've noticed here we've got this visibility private. We can have it private or public. Basically what that means, it's a way of setting who can see your API. If you create a public API, then anybody can see it. Anybody can come in and anybody can see what you've built. If you're building something for a commercial organization, that could be confidential. You don't want that to be made public, so you'd make it private. As I'm building this for a public demonstration. I'm going to make it public because I don't mind everybody being able to see it. Finally, this AutoMock API here. Do you remember what I said about when we build our APIs and when we do that collaboration, we're considering the testing as well as the development. The ability to mock an API actually means we have an endpoint available that test teams can hit instantly. As soon as we've created an API, we can start writing tests for it. Again, it is a great experience. It's that way of saying, okay, I've built this, let's get it used. I haven't written a line of code. There's nothing. The developers are still doing workshops, perhaps, they're still setting up environments. They're still deciding on tooling. They may not even know what language they want to build it in. But the testers don't need to worry about that because they're starting to build their tests. So I'm going to create the API. And what happens here is it's going to build this API structure here. So what we see here is this is the boilerplate that we've been given. It's set the Open API version. It's given us a little bit of information. So there's the version number, the title that we set, and the description. We can make the description much more verbose. We can add to it. So even if we decide, well, I didn't put enough information in the description before, I want to put more information in here, you can actually add to it in here because it's part of the live documentation. It gives us paths. The paths are actually our API endpoints. And then it gives us these servers. This server is this AutoMock server. What that tells us is when we write our APIs, when we put the models in, that's the server that the test teams can hit. That's the virtual server that they will be hitting to exercise the APIs that we build. Okay, so what we're going to do is build the simplest API possible. What I'm going to do, I'm going to build a get API, which I'm just going to get departments. Right, I've just deleted the brackets, and as doing that, what we see here is it's brought up this data bar here. The data bar actually allows us to go in and see any errors that we've got in there. So all I'm going to do is come back into the paths, and I'm going to create a path which I'm just going to call department. Okay. What we're writing this in is YAML. So it's very dependent on the spacing that we put in. You can write your definitions as JSON, but to be honest, I quite like the YAML. It works for me, so I generally stick with YAML. So the department, that tells us that that's an API endpoint. That tells us that there is going to be something for a department, but it doesn't tell us what the operation is going to be. So what I'm going to do is create a get operation. And what that's going to do, as you can see here, it's telling me there's information missing. It just knows I've created this department get. There's an error there. So I'm going to actually say, right, what is it that I want to do here? Well, I'm going to create a responses object. What the responses is doing is saying, okay, when I call this API, what am I going to get as a response? Okay, what I'm going to get back is a 200. So that's your HTTP status code. And that is going to be okay. So this is now, it's actually a valid endpoint. It doesn't do anything, but there is sufficient information here to say that that is now valid. What we need to do now is actually tell it what we want it to do. So what I'm going to do is give it some content. You may notice that as I'm typing for things like the responses, the description, the content, we're getting an IntelliSense. Again, it's really powerful and it's a really useful tool to get that information. I do recommend making use of it. We'll shortly see where it becomes much more powerful. So what I'm going to do in here is we're going to return an application JSON object. And what that's going to contain is a schema. So we're actually going to say what the schema of this is going to be. So the schema describes the API. So the type of it is it's an object. And what we're going to do now is say that it has some properties, and those properties are an ID. The type of the ID is it's a string. Now we actually want the ID to be a GUID. There is no native GUID type for the Open API. So what you do is you say it's a string, and then you tell it how you want it to be formatted using the format. And we want it to be formatted as a UUID. Now, I'm just going to go to another website here. 1 second. I want to give some good examples. So as I said, when we're building this API out, we want to put in some examples. That example is actually the thing that's going to be returned back when we make an API call. Now, before I finish building this object out, we do have on either side here, we have a description of the operations. So it tells us what operations we have available. And over here on this side, as well as the service, we actually have an example of the operations. We can try them out. Now, I'm going to show you a failing issue that sometimes catches people out and then show you what it means. If I wanted to try this out as it stands, I'm just going to execute this. It's going to give me a 4 back. It's going to tell me it can't find that. If you're ever working in SwaggerHub and you see that error, it means we've done some work on a definition and we haven't saved it. So save it, then try it out again. And there we go. We have an object back. Now what we see there, that's a curl command that can be issued. So your testers can start writing. It's telling us that they want to issue a get call to that address. We're going to get a JSON object back. And what we're going to get back out of that is that ID. Right away, we have something within less than 5 minutes, testers could start testing against. Again, we need to document this. We're going to give it a description. Because we want to create documentation out of this. Okay, now what I'm going to do next is I'm going to create a name property. It's all right, it's having an ID, but if we don't actually know what it's called, then it's not much good. So I'm just telling it that it's the name of the department, and I'm going to give an example of its guitars. Okay, I'd save that. Now, if I do this, if I do the get and execute that, it's going to return that object there with that it's a name and it's guitars. Okay, fairly straightforward, not that difficult to set up. Right, one of the things we have available to us is we can say that actually this set of names is going to be constrained. It's going to be a fairly limited set of items. So the departments maybe, from 2 or 3 names in the music shop. So what I'm going to do now is actually say, well, it's an enum. And the enumeration is it's either guitars or it's brass or keyboards or percussion. So now we have this enumeration that's been built out. That actually does build out as an enumeration for the API. So when we build out our API out of this, it will constrain to the guitars, brass, keyboards, or percussion. So let's save that. It's fine. We have an API and it works. Now, what happens if I also want to add an operation for, say, I want to say that I want to do a delete? I'm going to end up recreating a lot of this content if I wanted to do a delete. Sorry about that. So delete API. I'm going to be copying that and I'm going to be pasting that in here. And it's going to become, sorry, I just keep catching the wrong key there. I apologize. It becomes an absolute nightmare. You can imagine that having to recreate this structure for different items becomes an absolute mess. What we can do is actually create some little standards. So I'm just going to get rid of the delete. And what I'm going to do is create something called a component. And under that, I'm going to create some schemas. Now, the schema effectively is a central point to define an API. I've already defined the schema down here. We can see it. So we know what it's going to look like. So all I need to do is give it a name. So I'm just going to give it a name of music department. Okay, which is straightforward enough. And what I'm going to do under that is grab everything down here. Just paste that up to there. And all I'm going to do there now is I'm going to say that that schema uses a reference. So this $ref allows me to pick a reference to something. I haven't actually picked the reference yet, which is why it's coming up with this. If I press Control Space, I get a list there. It's context sensitive, so it knows what it's looking at. So I'm looking for a schema. It knows that it should be looking in the schemas object. So I'm going to pick the music department. If I save that, we now see that in here we still have the department. Down here we have a schema definition for the music department, it's the ID and the name. So if I go in here and execute this, I still get back that object. Okay. Right. One of the things we've noticed, obviously, is that that's as a path doesn't make much sense. Because we're saying we want it to be based off the department. The idea there is then you'd have only one department. So what we're going to do is actually say we want to search for a department. So we're just going to give it an ID. Now, the ID here refers to parameters. So under this, I could go in and do this, create a parameters object. The name is ID. So we're now saying it that whatever value you have in there, it maps into here. In here it tells it what type of object it is, whether it's a query string, a header, or a parameter, whatever. So what we're going to do, it's a path variable. we need to tell it whether it's required or not. Well, we're going to say that it's required is true. And we actually have to tell it what it looks like. Well, the idea, we're going to say it's a string. And finally, it's telling me that it wants a description as well, parameters and right. It's telling me it wants an array because we have parameters, and this is just a single parameter. So to make things an array in the YAML here, we just put a minus. The YAML is indentation sensitive, so we just make sure that we have everything lined up under there. And now we have a parameter object which matches. Sorry, so the schema type is string, space between there. Okay, so if I save that, you can see over here the actual shape of the API has changed. We now have the get, it's taking an ID. Okay, so if I go into here, we could see that we pass in an ID into there. So if I go in, just generate another GUID, copy that, it doesn't really matter. It's gone off and it's performed the operation. What we're seeing here is it's coming in and it is actually building up that path in that API, but it doesn't matter what value you're putting in. It's just returning a 200 because that's what we're telling it to return. This is the default return, the 200 series. So I could put a 404 in. So, you know, I could be saying, okay, well, it's returning a 404. And it's the description's not found. I save that and I execute it. Doesn't matter that I can't find that. It's just going to return the 200. So the testing gets you so far. There is going to come a point where you do need code with logic in that's giving you the different values. But for actually getting that initial confidence testing, getting the shape of the tests right, this example-driven approach is invaluable. Okay, now I want to delete operation. The delete is going to look largely the same as this. Or I might want the put, and again, the put is going to look largely the same as this. But as I put them in, what are you seeing? There's an awful lot again in here, which are boilerplate. So as I copy them down, I'll be recreating a lot of this structure still. So what we're going to do is we're going to create a responses. So all I'm doing is under the components, the same level as schemas, I have this responses object. And I'm going to create a particular response. The response I'm going to create is, I'm just going to call it the department response. Okay. So what is the department response? Well, it's just going to tell us that it has content, and the content is that. So all I'm going to do is just actually take that. And paste that in there. You notice again, the indentation depth doesn't matter. The error that's coming here is it wants a description. So for document response, some of these are the descriptions mandatory, some it's not. You can set standards so the description becomes all mandatory. So in the same way that we have this schema coming in here, what we're going to have now is I'm going to replace this entire content section here with a reference. So as I said before, it's context sensitive, so it knows that because it's in a responses section, it's looking for something that's in the responses in the component. So I'm going to pick the department's response. It isn't going to come as a surprise that we can also do the same for the parameters. So we're going to have a parameter in here, which I'm going to call the ID parameter. So the semicolon again is just used to end the item and to allow you to set the definition underneath. And what I'm going to do is take that, paste that in there, and I'm going to replace that entire section there with a $F. And I'm going to go in and set that it's the parameters and its ID parameter. Sorry. This. The full path is to the slash components slash. This basically tells it that it's searching inside this document, inside this component section, inside parameters for the ID parameter. So if I save that, that goes right down. Now what we've got here is an object that's come from being quite complex to something that's very, very narrow. So it's now a simple case. It's a lot less boilerplate code. If I go and say, okay, I want the delete operation, I'm only taking those. So now I have a delete and a get all at the same level. I might say, well, okay, I want the put operation. And again, if I save that, we can see now we've got a delete, a get, and a put have been created very quickly. Now, the standard here where we're saying, okay, that we're returning an ID, we're returning a department response, we've got an ID parameter going in. It's fine, but the 404s, we haven't actually given it any body. We haven't said what the 404 is going to return. It's just given us a description. What happens if we actually want to put some content in that? Well, that would tend to be the type of thing that would be standard across your organization rather than being just something driven by this document. So this is where we come back to something I mentioned earlier, which was the domains. So in this common section, what I'm going to do, I'm just going to create a new domain, set the OpenAPI version to 3, and I'm just going to call it common. We have versioning capabilities in this. So we can have version 1, we can have version 2, so on and so on. So what I'm going to do here is I'm going to say that the project is in common, and again, it's public. Now, when I go and create the domain, what that's going to do is create something that can be reused on any other API I wanted to build inside my item. So it's given us some general ones here. You can see that it's built up these default ones. Well, what I'm going to do is replace everything. And I'm just going to create this responses. The responses, it's going to be a response message, which has a description. The description is and I'm going to set the content in this. returning JSON schema. It's going to be, it doesn't matter if because this is something self-contained and only needs to be done in one place, I'm just going to define it in line. So the type is an object with the properties. These are a message and type of that string. Okay. So we're always going to have a message coming back. Now, what I want to do is actually tell the code that when we create this, we must always have a message. So what I'm going to do is say that we have a required object in here. We require a message. So you notice I'm using this minus syntax. If I save that, that gives us the array that says, okay, that required message is going to come back. Now, I could also put an array in, instead of putting it in like that, I could put the array in like this. It doesn't matter. It's just whichever you feel most comfortable with. So I now have a response message. So what I'm going to do is go back to the API. Now remember when I said about the My Hub, it actually put I said it would put things in this central hub here for quick access for your most recently visited. Well, that's what's happening here. I'm going to go in to the developer dev days music shop, and what I'm going to do is turn the 404s into another reference. Now, the reference that we're going to this time is coming from an outside. So I've done control space, and what we're getting is it knows that there's a domain object here. So it's going out to say, I want the response message coming from the domain. So that gives us a different looking API reference there, but it is still a valid reference there. So I'm just going to copy that 404. So right now I've created a fairly comprehensive set of APIs. There's a lot more we could do with it. The testers can test with it. People can comment on it. So suppose we had your product owner comes in, or your customers are coming in and saying, you know what, I'm not happy that we're only returning a 200 or a 404. They can actually comment on the API itself by going in and saying, okay, I want to add a show comments here, and I want to click this plus here and add a comment in. The comment I'm going to add is, I really want to see more API. So they add a comment. Now that comment is visible to everybody. It's sitting alongside the API. If we move things around, if we add more details in, it's still sticky. It sticks to that, so we don't lose the context. Just going to hide that. We get to the point where we want that to be available. We want to resolve it. You'll come in, you go and say, you know what, okay. You can come in and say, okay, Brian, you're the boss. You reply to that and you can resolve it. Say, okay, I've resolved it. It's done. If you want to share it with people, if you've invited people to join your team, if you've wanted to email it out, you can actually come in here and share and collaborate with people. So you can either take that link and paste it and send it to people, or you can email, you can invite them via their email or their username if they've joined. You can say what they can do. It's a great way, as I say, for getting that collaboration. So we've touched on two pillars of that API first approach. We've touched on the testing side, and we've touched on that initial collaboration with the end users, with the product owners, with development teams and so on. What we haven't done is actually built any code out of this. This is where SwaggerHub really excels. I can export code directly from here. What I want to do is come in and say, okay, I can generate code and I can send it out either as a server, or I can generate the client version. I can create some documentation out of this. I can download the API to be imported elsewhere. You might have something like an Amazon gateway, and you want to take in the resolved JSON, the resolved YAML, and import it into the gateway. You'd probably do that as part of your CI/CD process, and you've got that whole approach to really sharing out the information. So what I'm going to do now is create an ASP.NET Core server application. But before I do that, I'm going to add a terms of reference. There's a little gotcha in the standard template you get out for the ASP.NET Core. If you don't provide a terms of reference, when you run the application the first time, it'll complain because it won't find the terms of reference in the definition, and it is looking for URL. I'm just going to put any web page there. Okay, let's save that and generate that code. Okay. So if I go to the download directory there, I'm just going to generate that code. And I'm going to open up Visual Studio. What this has done is given us the data models that we've built. So that inline response 404 that we saw generated elsewhere, we've got a data contract for that. We have the music department schema. So that gives us that model that we want there. We have API controllers. So it's built up all of those controllers that we need, that we built out before, showing the Swagger responses and the documentation that we put in. But let's run it up. Let's actually start it to see what we get. So we now have, if you're used to building out your services and that with SwaggerHub, you'll be aware that with Swagger installed, sorry, you'll be aware that you'll get a Swagger page. Well, this has built that Swagger page out. It's just the standard Swagger definitions that have built it out, but it's that round trip. It's come from SwaggerHub that started, and we've got Swagger at the end. We have the APIs. Each one of these has values in, so we can go in and do the try it out and so on that we saw before. Yep. If I execute that, we get that response back. We've added no logic to this. There's nothing in there that's controlling or constraining what we're getting back out of that. We're just returning the value back. Okay. So that's that initial round trip on that model. Now, I did say we supported versioning, and one of the things that we've got here is that actually this model doesn't make a lot of sense, because what happens if we want to put a post in place? So I'm just going to add one final endpoint, and it's for a post operation. Okay, I'm going to break things quite badly now, but we will put things back together very quickly. If we post, we don't want to give it an ID. We just want to pass in the name, but we want to get the ID back. So what I'm going to do is create this little schema, which I'm just going to call the ID schema. So before I do this, let me just do one thing. Let me just create a new version, because we are breaking things. So I'm going to come in here, create this ID schema. And I'm just going to take that. Something's disappeared here. Okay. So that's given us this ID object. And what I'm going to do is add another one, which is called name schema, or name. You can call it whatever you want. Name schema. Okay. What I'm going to do with the name schema is I'm going to take that in. I'm just going to say that the type is an object. It has properties. And I'm going to set those properties. So what I'm now going to do is actually I haven't given it a the music department now is a more complex object. So what the music object is, it's made up of all of the ID schema and the name schema. So what I'm doing here is creating an array of references. This is a great way to build up more complex objects from simpler ones. So I'm just going to go into that. I want this. And I want this to be another reference. I want this one to be the name schema that we've created there. Right, the thing he's complaining about is we haven't created a post object here. So all I'm going to do is one final thing. I'm going to create a request bodies. And I'm just going to call this the department. And the description. From that, I'm going to add the content, taking an application JSON. And the schema that we want to pass in is just the name schema. So the request body here is we're going to pass in the request body. And that's going to return. So we're going to pass in the request body there, which is going to be that department request. So it's that $ref. So again, we always follow the path structure down. So it's request bodies. And the one we're passing in is the department. We need a response back because an API will always have something coming back. We now have a full post and get, so that a full post structure and a get structure there. That's version 2 of our API. We can go back to version 1 and see what it looked like there. We just had these endpoints. Then version 2, we've actually changed to add extra information. So this is where we get that whole round trip approach. Again, we can generate the code out after this, but we have one final trick we can do. When we release to live, one of the things we said is actually we can also produce documentation. So what I'm going to do out of this is come to here and I'm going to go in and produce this HTML documentation there. I'm going to show that in the folder. Extract that. And if I go into there, this is our developer documentation. That's the version. It gives you examples in different languages. So we've got the C# examples. If you want JavaScript or Java or your straightforward curl, it's got it all built in. It tells us what are required variables, what we get back, gives us complete documentation. We got this put, post, delete. All of this is being driven directly from this. We have a few minutes, and I appreciate it's been a bit of a whirlwind. This is normally a 2-hour talk. I've managed to cut down to an hour. So if there are any questions, is there anything anybody would like to know?
I think there's one in the published section.
Okay. What would you like to know? Sorry, my Teams questions has died on me. Just trying to reopen Teams. Would it be possible to read out the question?
Yep, that's fine. If we are sending data via HTTP API between two systems, are there any limits to consider for payload? For example, from source system, we want to send several million records to destination system using batches.
Oh, so we'll go right. Oh, that's where you step right outside of into API design. Yeah, so many ways you could handle that. This is where you get into an architectural discussion about how you build your APIs. Do you build plural APIs? So would you go in and build something like this, for instance? Would you build this structure? So music department, and its a type is an array, and the items. So would you build it up like that type of structure, which creates an array of those, and then pass that all across? Or would you consider sending them, just saying, okay, I'm going to send them one at a time and one at a time? API to API with millions of objects, you've got the big questions you've got obviously latency comes in. How long is it going to take you to transfer that data over? Are you going to be able to keep a connection open for that long? Architecturally, what happens if the connection goes down? If you're doing it on a one at a time basis, how does it know at the other end that it's finished getting all of the data? It does become a conversation that the two sides need to have together. That's a conversation you need to have with the client to say, if I send you millions of records like this, are you going to be able to cope with them? Or should we be looking at alternate mechanisms? Should we be doing things like, compressing the data down, doing them zip, or going for something different? And this is where I would actually say, rather than using a RESTful API, that's actually the type of thing that you'd more likely want to consider gRPC for, because that is much better for that scale of data. That doesn't actually preclude SwaggerHub, because the thing they're working on right now is the ability to do gRPC out of your definition. So you build your definition out, and then it creates the gRPC. So, you know, that's something I would definitely consider. But it's one of those, it depends question. It really depends on what both sides would agree on, fault tolerances, whether you can batch them up into smaller batches, you know, the whole architectural area. I hope that answered the question. Is there any other questions?
One more that says, does SwaggerHub support GraphQL and or Async API standards?
Right. At the moment, no. Async API is something that SmartBear, the company behind SwaggerHub, are investigating right now. I've been in conversation with them recently about GraphQL. It is something that's on their longer term roadmap. It just isn't there right now. So neither async APIs nor GraphQL are there right now, but async APIs, I believe, and this is just my impression, my recollection from conversations I've had with them, will be along quite soon.
I think that's everything.
Cool. In which case, I would like to thank everybody for attending. A final reminder that we have a Just Giving page for the National Museum of Computing. I hope everybody's okay and has managed to weather what has been an awful year. And thank you for attending. And if you have any questions, any comments, any help you need on SwaggerHub, reach out to me. I have a good working relationship with SmartBear. So if there's anything, any other information you need, and can put you either answer the questions for you, or I can put you in touch with the people who can get you those answers. They're really, really good about being helpful and about engaging. Thanks, everyone, and have a great Christmas. Merry Christmas, everybody.